Well, you did at CIS 276. You survived the first half of the material for Chapter 7. And really, if we look at it in terms of the breadth and length of the material, you've survived most of Chapter 7 already. The STL vector, that's what we'll spend today talking about. That's the rest of this week. And it is your last project for the course is using the STL vector. So I just want to do a little bit of setup here to talk about the vector and how it's the same as an array and how it's different from an array. So first and foremost, a vector does what an array does, and it holds a homogeneous sequence of elements. So, a vector can be of type int, of type float, of type char, of type string, etc. Just in the exact same way that an array could be. Because I did not give you the page number, I will do that here. This is on 435, and it starts there's really not too many pages worth of material here, but it starts our journey here with the STL vector. Next, the vector stores its elements in contiguous memory. So just like you'll recall with the array, if we have 5 elements or if we have 500 elements in an array, they are stored contiguously. So from 0 to 4 or 0 from 499, they are stored sequentially in memory. That's actually the cost benefit of an array. They're very, very fast because some of the underlying architecture that we won't have an opportunity to talk about here in Introduction to C++, but next semester or next class, whenever it is you take Advanced C++, we'll talk about some of the ways that we will actually, as developers, have direct access to some of those real hardware level concerns. And that's why, again, we pick C++. So getting back to the array, and here in 276, so they are in contiguous memory locations. So when we iterate through our array, it goes incredibly quickly because C++ knows where that array begins and where that array ends and how many elements are in the array. So that's actually going to be one of the things that diverges here between the array and the vector. And we'll talk about those in just a second. But they both have that same behavior, is that they are both, the array and the vector, stored contiguously in memory. And you can use the subscript operator, that is the square brackets, and an element number to read an individual element of an array. And similarly, that's the word I was looking for, similarly, you can use that subscript operator, the square braces, to be able to read the contents of an element in a vector. So those are the things that are the same. And again, this is all here on 435. But how do they differ? So first and foremost, you do not have to declare the size of a vector, whereas you do have to declare the size of an array. So when we were declaring arrays, we would use either a constant int or we would have an int that we would get, for instance, from a user, so that we could, after user input, we could declare the size of an array, etc. But you do have to, with arrays, declare a size. With a vector, you do not. So you can instantiate a vector simply with a call to a vector instantiation with its type. You do not have to specify a size. And we will see that in the code sample here that follows. Next is, with an array, we could not add an element to an array that was already full. So if I from our previous example, a 5 or a 500 element array. When I go to add, when I go to add my element number 5, so that's my 6 element, or when I go to add element number 500, which is actually my 501st element in the array, that is simply uncaught. It does not go to anywhere. Here, with a vector, what essentially happens is C++ will either take the next location in contiguous memory or work to move your entire vector into a space that has enough open contiguous memory to accommodate the new size of that vector. So if we have a vector of size 5 and we add our 6th element to that vector, it will, from our perspective as a developer, simply add onto the back end of that vector, which feels honestly like magic after working with the array and after coming all these months through C++, to finally get something where you have the flexibility, I think, to do what many of you as developers have wanted to do since like sessions, 1, 2, 3. This is a revelation. You mean I can just keep adding to the back of a vector and C++ does all the work for me? Yes, it's pretty great. I will admit it's pretty great. But do remember, all of that greatness comes with a compromise. When we are running our code samples later on, keep an eye in the lower left-hand corner of your repels. Keep an eye on the CPU and disk usage. They get very, very used during vector operations, especially some of the larger vector operations. Finally, a vector can report the number of elements that they contain. We use this with size. So we will see this in our code samples, which we will have one more quick video. We'll go over a table really quickly here that we can see some of the functions that are associated with the vector. So vector and arrays, it's the reason I've broken them out in this way is they are very, very similar. Most of the nomenclature you can use for a vector you have already learned how to do with the array. We just have the ideas here. I'm going to peek ahead a little bit. It's push back and pop back, and we'll see that really soon.